This is our first broadcast of what will be a series of training videos designed to help IT folks like yourself become more familiar with tools and processes that are currently available. Our overall goal is to, number one, educate those new to design and modeling. Number two, foster more utilization of the newest technologies and methodologies within our industry. And finally, number three, help align practices across the various IT groups within a company in the hope of realizing some gains in efficiency and reduce time and money spent on maintenance and redundancy. We will begin with a discussion about modeling and architecture and move into videos that deal more with actual use of some of the latest technologies. Let's get started. This presentation will focus on design and architecture, with some focus given on modeling and some of the challenges IT faces when attempting to design parts of a system prior to the actual coding process. As you can see, I have subtitled this page, Surviving in an Agile World. Many companies have embraced the Agile development model, which focuses on the ability to adapt quickly to change. Sometimes this is in conflict with more traditional development models, and we'll discuss how these two methodologies can coexist. So let's review the agenda. First, we will formally define the term modeling, and hopefully in a context that is recognizable to your environment. Next, we'll discuss why we should even consider modeling a business solution. Then, we'll go into more detail about Agile development practices and how it can coexist with design and architecting software. Next, we'll review some of the tools which are available to help you get started with modeling. Then, we'll discuss the importance of making the design process habitual and fostering a culture of modeling within the various groups within your organization. We'll wrap this up with a summary to try and tie everything together. Finally, we'll give some resources that you can review on your own to help reinforce some of the material given in this demonstration. But before we begin, I'd like to make a comment that this is going to be more of a conceptual discussion. In future broadcasts, we'll get more in depth by using tutorials and sample code. So if you're looking for a tutorial in this video, please check back in the next few weeks as we'll be introducing weekly videos. So let's get started. So first, let's give a formal definition of a model. A model is a pattern, plan, representation, especially in miniature, or description designed to show the structure or workings of an object, system, or concept. This is really what modeling is all about, right? Giving a graphical representation of an existing or proposed system. Various kinds of modeling languages are applied in different disciplines, including computer science, information management, business process modeling, software engineering, and even systems engineering. They can be used to specify system requirements, structures, and behaviors, and are intended to be used precisely to specify systems so that stakeholders, like customers, operators, analysts, and designers, can better understand the system being modeled. The more mature modeling language, however, are precise, consistent, and executable. Informal diagramming techniques, like whiteboarding and some workflow applied with drawing tools, are expected to produce useful pictorial representations of system requirements, structures, and behaviors, but really not much else. Executable modeling languages, on the other hand, applied with proper tool support, are expected to automate system verification, validation, simulation, and code generation from the same representations. A good example of this is Power Designer, which can generate and execute SQL scripts directly from a physical model. The Standish Group is based in West Yarmouth, Massachusetts, and the goal of their group is to increase the value of IT investments. However, they're probably most famous for their publication of the Chaos Report, which gives empirical data in regard to IT projects. So as we can see from this chart in 2000, that less than 30% of IT projects were considered to have succeeded based on the parameters that the Chaos Report has set, which includes both cost, time, and delivered functionality. It has improved some, and in 2004 the success rate was 34%. If we dig further, we find that on average projects exceeded budgetary estimates by about 45% and exceeded time estimates by over 60%. Finally, as you can see, functionality had a fairly low delivery rate of only 67%, which means that on average only 67% of the requested features were delivered to the users. Now the group who has researched and come up with these reports have most recently attributed some of the modest gains in success to better development tools which allow for developers to more quickly perform simple tasks. However, they also have recognized with the advent and popular use of RAD, that is Rapid Application Development Techniques, which is a part of the Agile programming domain. One thing they do emphasize is that the major challenge that IT projects have is the gap between what users actually want and what they request. In addition, most projects that fail in the three measured areas are due in part to a lack of rudimentary object-oriented development techniques, and we'll certainly go into OO development techniques in detail in future broadcasts. Here are some well-known benefits of modeling. Documentation. Decision makers need to have good documentation of business processes so that others can understand how they work, who's involved, and how activities flow from start to finish. Documentation is the end result of proper modeling techniques and is invaluable in every aspect of the project development lifecycle. Redesign. Companies are always looking for ways to improve their business process to reduce inefficiencies, save money, and most importantly, react quickly to changes in the business. However, you simply cannot redesign a process unless you understand it. Without a well-documented system, we have to rely on developers stepping through code and analysts clicking through the application to understand it. Execution. In most cases, the best way to improve the efficiency of any process is to apply some sort of automation to it. With automation, processes can be performed faster and at a lower cost. However, it's important to recognize processes that are inefficient by nature. In this case, a redesign prior to that automation is the preferred approach. Now, one problem we all face in IT is communicating the importance of certain process improvement changes within our group unless it has a direct benefit to the business we support. Here are some reasons why the business should invest in training in regard to modeling and architecture. Business alignment. As you probably already are aware, companies invest heavily in the alignment of different business processes. When reviewing redundant processes and deciding on consolidation, it's extremely difficult without detailed supporting documentation. Government regulations. Some countries, including the U.S., require that business processes be properly documented. For example, the Sarbanes-Oxley Act, in particular Section 404, regulates that certain processes must be well documented in order to avoid scandals in the IT arena that we've seen in the past with companies like Tyco and Adelphia. Finally, business involvement. By allowing the user to visualize the process, which typically is only in their head, it promotes a more structured thinking and helps them better understand the structure of their current process. Further, it helps bridge the communication gap between a business understanding of a process and the transition to the IT thought process relating to it. However, it's really presumptuous to think that any project will have all of its requirements defined up front. Going through the modeling process during requirement gathering phases helps reduce that gap tremendously.